see both. Okay, now.
Yeah, it's normal. Expected. Okay. Well, welcome everybody. So I will try to introduce the main Tango concept in 15 minutes. It will be very short because usually we have 1 hour to do that. Fasten your seatbelts because this will be fast. So Tango controls, it's a control system framework. So the main goals of a control system framework is to control all kind of equipment in the same way and to hide how equipment are connected to computers. So if they are using networks, airlines or USB or whatever. And also to support any equipment supplier. The main idea is to hide the network between the computers and do not ask the user to know on which computers equipment are connected. And it will also provide control system framework provides as well services for the users. So usually you have easy ways to write graphical user interfaces. You have data archiving services, alarm services, web access. So let's focus on Tango controls, which is an object-oriented distributed control system framework. It defines a communication protocol and an API, and provides a set of tools and libraries to build a software for control system, especially SCADA. So this we already said. So Tango Control is a free software. The core libraries are under LGPL license, and most of the device servers and tools are under the GPL license. So let's talk about object-oriented programming in general. So when you do this kind of programming, you have some objects and you can execute some methods, and the objects, they can communicate with each other, and so you can execute some method, you can read some data members on this objects. They are usually written in an object-oriented language. So you have different languages, potentially. And your objects, they might be in different processes, in different applications, and they can be on a given host with a specific operating system. And the idea is to be able to communicate, to make one object communicate with another one, which is in another application. And this is usually not so easy. I mean, you need to use like some shared memory or files or things like that to communicate between processes in general. And also you can have like this kind of objects, but on different computers, and you would like them to communicate as well from one computer to another in an easy way. And this other computer might be using a different operating system as well. So you have all these red barriers that you would like to remove. So you would like to, whatever the language, wherever your object is running, on whatever host, you would like them to be able to communicate in a transparent way. And this is what is called a distributed application, and this is what Tango is providing. So it's basically a software bus for distributed objects, but it's even more than that because you have as well some services, and there is support for many languages. And all these objects, these distributed objects, this is what we call a device in Tango. And a device, we will talk a bit more later on, but you can do, a device can represent many things, many different things. So here I'm just listed some of the main languages which are supported on the client side, and as well some of the tools which are there to help you to build some graphical user interface, like Taurus, Tango ATK, Qtango, and there are as well some services like HDB++, which is something to archive some events which happened on your control system. The supported languages are listed here. On the client side, you can write clients in C++, C, Java, Python, MATLAB, LabVIEW, Igor Pro, REST API, and there's a new one, a recent one, Rust as well. And on the server side, you can write your device servers in C++, Java, Python, and LabVIEW. So the Tango device, this is a fundamental brick of Tango, and it's basically a distributed object which is exposing an interface. So everything which needs to be controlled is a device, and from a simple piece of hardware, so flow meter, for instance, or sophisticated set of hardware like a radio frequency cavity or a big antenna, or every device has a 3 fields name. So this is a name of a device, and the 3 fields are split like this. So there is a domain, the family, and the member. So here are some examples. For instance, here we have the motor of the absorber on the front end of ID08 beamline. So a device name must be unique in a control system. So these are just some example of devices. Like here you have like some vacuum pumps and flow meters, and here you have a radio frequency cavity, for instance. So the device is one entity to be controlled. It can be hardware or software. So you can have like, it can represent a physical device, can represent as well a logical device. So it can represent an equipment, a collection of equipment, like for instance, a combination of motor and encoder. Devices aggregate, like to represent a complex system, like a beamline. The whole beamline can be a device. One application, like one agent of the archiving service, for instance. So what is nice with the Tango concept is that you can really interface complex systems and represent complex systems using a hierarchical structure. So for instance, you can have like a high-level device representing an accelerator or diffractometer, which will talk to some sub-devices, power supplies, motors, CCDs. And these sub-devices can also talk to some other sub-devices like ADCs, Modbus, whatever. So it's an easy way to represent and to solve some complex, to represent some complex systems as well. So every device belongs to a Tango class, and every device inherits from the same root class, which is the device IMPA class. And the Tango class implements the necessary features to control one kind of equipment. For instance, you have a Tango class to control this spectrum analyzer. This is just an example. Then we have the notion of Tango device server. So the Tango device server is something which will be able to manage different Tango classes. And so for instance, here we have a device server, which is basically the executable, which is able to manage class A, which is a kind of Tango class, and class B as well. And these classes, they can expose whatever number of devices, and this is configurable. We will talk about it a bit later. And in every device server, there is what we call the admin device, so an administration device, which is always there, and which has a name which starts with dserver / the executable name / the instance name of the device server. And this admin device helps you to manage the devices, to restart the device, to kill the device server process. For instance, there is a command to do that, and so on, and to configure in general the device server. Okay, so Tango uses a database to configure a device server process. So the device numbers and the names for a Tango class are defined within the database. They are not defined in the code. And which Tango classes are part of a device server process is defined in the database, but also in the code. So, but when you build an executable, you have to link all the classes, all the Tango classes that you would like your device server to support.
Reynald, there are 4 minutes left. Sorry.
Yeah, I speed up. I will skip that, and I will go to, okay. Every device has a state, which some commands, at least 3 commands, so init, state, status. So the commands, they are basically actions that you can do on your device. You should see that as actions. Every device has some attributes, so at least 2, state and status. And the attributes, they represent some physical values and that you want to control or monitor, like a temperature, motor. And you have also some pipes. So this is dynamic data, which type can change at every call. But this is quite advanced. And then you have as well, one thing which is important, the properties, which are configuration parameters. So here's just a simplified Tango device server model. I will skip that because basically this is what we said just before. There is a more complex one. I will skip it as well because it's a bit too complex and we don't have enough time. So on the network, the Tango device mainly has commands and attributes. That's what we said. A command may have 1 input or 1 output argument. There is a limited set of argument data types which are supported. They are here. And the attribute, they can be self-described via configuration. You have 14 data types which are supported. Like all this one, you have some enumerated as well, and a special type which is dev encoded, which is basically some bytes that you can just pass. You can have the attributes can be read-only or read-write. They can be scalar, an array, or images, so spectrum or image. And also, the set value of an attribute can be memorized, meaning that when you restart your device server, the set value can be restored and optionally applied or not, as you wish. This is an option. An attribute, when you read an attribute, you can receive, so you receive the data of the attribute, potentially an exception in case of error, a quality factor, saying that, for instance, the attribute is not valid, the data that doesn't mean anything in the current mode. You can have some alarms as well, quality factors. There's a timestamp associated with each read value that you receive. You get the name, the dimension, data type, and so on. And when you write an attribute, you just give the name and the attribute data that you want to write. Okay, let's skip that. So here are the 14 device states, which are available. We have some tools to be able to generate some simple state machine saying that, okay, this command is not allowed when the device is in the off or moving state, for instance. And the same for the attribute, you can distinguish read and write. Then you have the properties, which are, as I said, configuration parameters. They are stored in the database. You can use some tools to create and delete them. You can define properties at class level, attribute level, system level. And by default, an history of the last 10 values of your configuration parameters is saved in the database. So Tango system is basically a set of device servers which are managing some set of devices plus a static database. I will skip that. And I think we are already over the time. I'm sorry. One thing important is that we have some code generator named Pogo, which allows to define the commands, the attributes, and also to configure the basic settings for all of them. And as a device server programmer, you will just have to concentrate on the part of which will talk to your hardware. And so you will just concentrate on what does the on command. You don't have to handle all everything which is there to handle the client calls. So Tango while Pogo will generate all the code to handle that for you.
You should finish
yeah,
in 1 minute maximum.
Yeah, so this is just an example of the tools with many things that you can configure on the attributes, some alarms. Just an example of a generic application, ATK panel. And there is one thing which is important as well, is the polling. Polling a device is basically periodically executing a command on a device and storing the result in a polling buffer, a circular buffer. And this is done at the server level, a device server level. And we have a thread which is doing that for you. And it is very easy to configure. Okay, and then in the important things to know, there are 3 ways of communication: synchronous, asynchronous, and event-based. And we have many different types of events, and I don't think we will have time to go through them. And I think we can probably stop there because we are already over the. There are many
Yes,
things.
I'm really sorry, Reynald, but the agenda has had 15 minutes for this talk, and it's clear that more than 65 slides is too much. But maybe it's good if you share these slides with all of us, and then
that was the idea. That's what I was thinking.
Yeah, thank you. So our next speaker is Benjamin. He will share with us an installation of Tango session. No. So Benjamin, it's your turn.
Okay, yes. So let me start. So yeah, today we'll just go through the different ways to install Tango. So we'll see a list of different methods very quickly. So first I want to remind, so as in Reynald's presentation, you saw that Tango is a distributed system and it relies on the Tango database. So to be able to work with Tango, you need at least one Tango database, which is a device server, this database DS running. And this is using MariaDB or MySQL to store all the configurations. So when you have that, then you can, if you want to run a device server, there are different things. Usually you install Tango Test, that's a device server that is used for testing. You have Tango Starter to handle automatically the restart of device servers. And then you install usually the libraries for language you want to work with, so C++, Python, or Java. And often, so you have more graphical application or command line tools that we call Tango applications that can run on different hosts. So we have all the Java applications that are provided. When I mentioned as well, Jive, there's Astor, that's to restart device servers. And the same, so Tango libraries to develop the application you want. And so all that can be on different machines, or you can install, of course, everything on the same machine. So one thing I want to mention as well is that as all those applications, they need to communicate with the Tango database, you have to specify where the Tango database is running. So that's done with the Tango host variable. And on Linux, the check is done in this order, the Tango host environment variable. And if it's not defined, then you will check in your home directory, the .tango.rc file. And if it doesn't find that, you will go to the etc tango.rc file. And on Windows, you have the equivalent, basically. So to speak about the installation itself, I will first mention the installation from source. So of course, it's not the most straightforward way. It takes a bit of time, but I think just good to know. So we migrated to GitLab recently, so you have a repository here. But so the latest release we made is still on GitHub. We haven't released anything new yet since we migrated to GitLab. And one good thing to know is that so this distribution, so it's a big archive. It comes with all the jar files for Java libraries and applications. So and all those they come, so they are precompiled. So all the Java application basically you can use directly when you download this source distribution. And for the rest, then you have good instructions in the README, and you have to install the dependency and compile everything yourself. But so to speak about the first easy way to install Tango, so we build the RPM. They are built on Copper now, so that's a build system and infrastructure provided by Fedora. And we built for two versions of Fedora, I think, and CentOS 7 and CentOS 8. And you can use Copper so as a repository to install Tango directly. But so if you are on CentOS 7, I recommend using the Max4 repository. There's a public repository that we make available. So we just need the EPEL repo as well and this Max4 repo, and then you can install Tango. So to do that, so first to install the Tango database, you need to install MariaDB. You start the service, then you install a TangoDB package. And the first time you install that, you will have to create the Tango database manually. So you have to run this createDB script that is part of a TangoDB package with just some simple questions to answer. You can basically leave a default. And then you can create this etc tango.rc host, as I mentioned earlier. So you just set the Tango host and you put the host name basically of the machine where you are running TangoDB. If you want, for example, you can configure under profile D to set the environment variable as well, but it's up to you. etc tango.rc file is enough. And once you have done that, basically you just start TangoDB services. It's a systemd service, and you have Tango database server running. And to check that everything is working properly, you can start the Tango test device server with Tango test, and you should just see ready to accept request. And if you see that, then you know that everything is working as it should. So then if you want to install PyTango, for example, to work with in Python, there's a Python 3.6 package called Python 3.6 PyTango that you can install. And for the Java application, you have a Tango Java package that will install all the Java application, basically. So for example, see, if you install this package, you have Jive that you can start running directly. On Debian and Ubuntu, there are packages in the official repository, so you don't need to configure any specific repository. It's not the latest version right now, it's still 9.2, but it's a convenient way to install Tango on those platforms. So you just, same as on CentOS, you install MariaDB server, and then you install TangoDB. So on Debian and Ubuntu, there's an interactive mode during installation. So when you install the package, it will ask you a few questions where your MySQL host is and what's your Tango host name. It will be pre-filled with the host name of your machine. And so when you answer that question after, it means that it will automatically create the database for you and start the services. So and it will even create this etc Tango RC file for you. So once you have installed it, ready, and then you can again try with Tango test to check that everything is working. Just can note that it's installed in a specific path, user lib Tango. On CentOS, it's directly under user bin that we put usually the binaries. For PyTango, so you can install Python 3 Tango. There's a package as well. So again, I don't think it's the latest version. So as you see, it's 9.2.5. And for Java, there's no package in the official repository. There are some license issue with Debian, but Frederick Pika has a package that you can download and install, and you will be able to install the Java application on those platforms as well. Yeah, just one thing, be careful just to use Java 8 because this version of Java is not compatible with Java 11. So if you have Java 11 already installed and set as default, you should change to use Java 8 as default. The new version of JTango is compatible with Java 11, but so all the applications haven't been repackaged yet. Next way to install Tango is with Conda, which is open source package manager that runs on any platform. So we pushed this year many packages to Conda Forge. So they are Linux only right now. And you see the list here, there's Tango Starter and Tango Access Control that should soon be available. And it's quite convenient way to install Tango as well, because so all those packages, they work on any Linux distribution. So it can be CentOS, Debian, Ubuntu, whatever. The same package will be able to run. So Tango database, if you install it with Conda, you will have to create the database manually. So there's a create DB script that is part of this package as well. But then you will have to create a systemd service or use supervisor or something to run it as a service. But otherwise you can run that in Docker as well. It's quite convenient. So for Windows, there's a PyTango package that is available only on Tango controls channel right now. But so we are working to make those packages compatible with Windows as well. And to install Conda on your machine, if you haven't done that already, I recommend the MiniForge, which is basically an alternate installer. It's an alternative to Mini Conda, so it's provided by Conda Forge. And it comes already configured to use Conda Forge channel by default. So it doesn't use the Anaconda default channel. So if you just download the installer, run it, you will see that you have directly only Conda Forge. You don't have this default that you usually have to point to Anaconda. And then it's very easy to create an environment. So for example, here you create an environment with Tango test and PyTango. And you see that you can use Python 3.9. We have 3.6, 3.7, 3.8, and 3.9 that are supported. Another way, which is very popular because it works on Linux, macOS, and Windows, that's Docker. So for example, if with this Docker compose file, if you just run Docker compose up, you will have Tango running, so with a database server, Tango access control, Tango test. And because here this container is just MySQL running with already the database properly configured. But so for Docker, there are many other images available, and especially from SCA. I think there are many sessions later today that will speak about Docker and give some examples. So I won't say more. I wanted to mention a bit more Windows. So with many other things we spoke before, it was a lot Linux specific. But on Windows, there's an installer, Tango Setup. Again, yeah, it's not the latest version, but it's an easy way to install Tango on Windows. It comes with almost all the Tango applications. So there's the database server, there's Jive, and so you can download it from here. And you have the instructions and read the docs documentations. And if you just want to install a PyTango, you can use pip because there are wheels that are supported for Windows. That's not the case for Linux today. We only have a source distribution for Linux, so I don't recommend installing PyTango with pip on Linux because you'll have to compile it basically. So it's Conda is much easier. And I already mentioned the Tango controls channel, so you can install PyTango from there.
You have 3 minutes, Benjamin.
Yeah, I'm almost done. Yeah, just the Tango box I wanted to mention as well. That's a virtual machine that comes already configured with Tango controls and many tools. So if you have just VirtualBox locally, just download the image and you can test in that virtual machine. It's quite convenient, so for testing and demo. And that's it. That's all I wanted to say. So you can see that there are many different ways to install Tango. So on Linux, you have RPM Debian package. You can use Conda as well, Docker, of course. And on Windows, you have binaries available. For PyTango, you can use pip or Conda. And of course, there's Docker or virtual machine. And for macOS, yeah, you have the choice between Docker and virtual machine because CPP Tango doesn't really compile yet on macOS. And at the end of my slides, there are a few links. So there's the read the docs documentation. So I think where I took most of the instructions to install Tango, and so a few other links. And that's it.
Thanks, Benjamin. So now, as Vincent shared in our chat, the next session is split in 2 different rooms. In Shanghai, you will meet Piotr with an install party hand-on session. And in the Beijing room, Matteo Di Carlo will share with us a hands-on session about Kubernetes for SKA. So see you later in this main room.
Just small clarification: the hands-on on installation will be led by Michał Gandor.
Okay.
But
Thanks.
it's just I will also be in the room, but it will be Michał who will provide.
Okay, so there is already some people there.
Yeah.
And the rest of you that are still here, I don't know if you know that if you are in Zoom, there are breakout rooms icon on the bottom that you can click and then select which room to join. And for those ones in WOVA, I don't know how you join that room. So maybe Vincent, I don't know if you can give instructions on how to join the rooms with a WOVA application. Because
even with the Zoom, if I may interrupt, I can see the rooms, I can see who joined them, but I don't know how to join the room.
So the list, there is a join link on the right of the list. Of rooms.
You have to hover above the number of participants. Okay, found it. Thank you.
Yeah.
Mm-hmm. So Vincent, I will start counting the time right now. 5 minutes late.
Yeah, that's okay. That's good.
Okay.
And so for the people that are still in the room, if you have any question on how to join the room, the breakout room.
Vincent, I'm going to join those rooms and see that everything is working and come back here, okay?
I can join the Shanghai if you want. I can, and you join Beijing. Is there any people that want some help to join the parallel session? No? Okay.
I think, Vincent, we can chat here. There is not much people. So I don't know how you want to manage this. The chat is global, I think. If you enter in the breakout room, we can write another message.
So I have in the breakout room, I have the possibility to broadcast a message to all,
okay,
and also to close the room, so we can.
Okay, but I wouldn't close.
But I don't know if
talking. So
maybe I can. I send a message like 3 minutes left.
Yeah. 3 minutes left in each of the sessions, but I think the chat is shared. So. Or you enter in each.
No, it's a feature of Zoom. I need to.
Okay.
Broadcast. I think it display.
Yeah, I see it. I didn't see this. And how you send that? Is in the chat?
I think it's display on everyone's screen.
Yeah. But how did you send this broadcast message?
In the breakout room window, on the bottom there is. I have 2 options: broadcast message.
Okay. I don't see that. I only see the room names.
Yeah.
Okay. You as a host can manage this.
Yeah.
Okay. Good. Well, let's wait. Who prepared this agenda so tight?
Yeah. Who decided to have a virtual event? It's hard to. Yeah, we could have chosen to.
But it's good to have a broad view of concepts. Yeah. At least one session seems that is finished, or are these people is joining back? Or maybe it's people that left.
I can check.
Okay, I think the Kubernetes one finished because people is joining us back. Okay. This is good. There is still the same people in the Shanghai room. Okay. Good. I think people is joining back.
So Matteo, what was the challenge to explain Kubernetes in 15 minutes?
I've done it. I told you I was perfectly on time. I told you I've cut out the debugging.
Good. So it seems that the other session is just still running. People is not leaving Shanghai room. Let's wait 1 minute more.
Yeah, maybe in the meantime, Anton.
Yeah.
And prepare. Can share the screen.
Anton is already here, and I guess Nicolas is also here. Yes, good. So I think I will join Shanghai room for a second and ask them to finish because people is still there. So I'll come back in a minute.
So Matteo, did you have time for question?
I asked for question. I had 30 seconds. But yeah, no question for me. So I guess I was very, very fast. It's really hard.
Yeah, but this is good that you have some materials that the people can try offline. And
Okay, Vincent, people is already joining. I had to interrupt abruptly because they were talking, but since the agenda is really tight, I think we have to continue. Yeah. So let me check. There is only 2 people left in Shanghai room and 2 more people in the other room. So I guess they will join us later. So welcome back, everybody. The last talk for this first session is a hands-on session about this Python server and a client example done by Anton and Nicolas. So go ahead, please.
Okay, thank you. Yeah, this is going to be very quick. Thanks for joining. I'm with the South African Radio Astronomy Observatory, Cape Town. I'm working on the Meerkat and Square Kilometer Array radio telescopes. And Nicolas is at the SRF. So I want to thank a couple of people that contributed to the slide deck. The agenda is got some bits cut out. It's part of a much bigger Pytango training course, and which takes a few hours. We've only got 10 minutes. You might have seen that you can download a version of the slides, bonus material, which is everything. So that might answer some of the questions you have. We can chat more at the end of the meeting if you have specific questions. All right, if you've never heard of Pytango, it's a Python library which wraps the C++ Tango library. So in the software stack diagram, your Python application is at the top, Pytango in the middle, and CPP Tango and its dependencies are underneath. Right, we're using Docker Compose because it's an easy way to run everything on different environments. Setup we have is 4 containers: the Tango database, the database DS, Tango test server, and then a container where we can do command line work. And these all connected together in Docker network. Inside the CLI container, the /training folder is volume mounted to the training examples. And you can find all of this on the GitLab repository for Pytango. It's a readme there. Hopefully some of you have done these steps already. So you need to create that network the first time and then run Docker Compose up. You might get a few errors. Hopefully you'll see this ready to accept request for the database DS and the Tango test servers. Right, the most important part is really what does a device server look like in Python? Here we have example. It's very short. It's a power supply device. The important part is importing from the Tango library. So this is Pytango. We import the device class, and attribute and command. Then we make a class which inherits from device. Right. This is called power supply, and it's got 2 methods. The first method is voltage, and this attribute decorator means that it becomes the Tango attribute. The type will be float. There are a lot of other keyword arguments you can specify here to further define your attribute. This one is just returning the simple value, and in this form, it will be a read-only attribute. For the command decorator, we put that on a method, becomes a Tango command. Again, there are keyword arguments if you want to specify the type of the data coming in and the type of the data you're sending back. This simple example has no input and no output. When we run the script, we can use that same class as a convenience method called run server. That will start our device server, and inside that device server, there will be a single instance of this power supply device. The source code is also on the Pytango repository under training. We can try and run it. So if we use Docker Compose, we can execute bash inside the CLI container. We go to the server folder. We can then try and run the Python script. It's got a few command line options. We have to specify the instance name. So if I use test, initially it'll complain and say that this doesn't exist in the Tango database. Right, every device server that you run has to be registered in the Tango database. You have to give it a name. So we could use Jive to configure that, or we can use a command line tool called Tango Admin. It's got an option called Add Server, and we could use that to register this class in the Tango database. This is the command line you would need, -- add server, specify the class and the instance name, again, the class, and this will be the Tango name when we try and access it through this string. All right, just show you that running. So here I've got Docker Compose running in another terminal. I've got bash running inside the container. I've already registered the server, and then I can run it. If you want to get a lot of debug information, you can add a -v. Level 5 is the highest, so that will give you a lot of information on what's going on with your server. Then if you want a client to connect to that server, you can do that through IPython. You can import the Tango library or Pytango, make a device proxy. Then we need that string, which is the Tango name, train/ES/1. Has a method called ping, which just checks the communication between client and server. That's the time. And then we could read the attribute of voltage directly, or we can call the calibrate command. It doesn't take any parameters. So that's a very simple client interaction with our device. Look at a slightly more complicated example of a device server. In this case, we have one that's connected to some external hardware and is talking to the external hardware via TCP. So now we import from the socket library the create connection method, and then from Tango we have the same thing as before. We've added device property. A couple of methods here. One to connect to the server via TCP. This write read line is going to send TCP messages. So it's really our communication with the hardware. And then again, our power supply device. So here we've added the two device properties. So host is a string, port is an integer. These are the connection details to talk to that hardware. And the idea is that these will be specified in the Tango database. It's configuration information. If you specify a default value here, then when the device starts up, if it's not specified in the database, it will use these values. Obviously, for each instance of the device you have in your control system, you probably want to specify different connection details. The Tango makes it very easy for you. Init device method is called when the device is initialized. So we're overriding this method as part of device. We need to call the superclasses method. That's when it will fetch these device properties from the Tango database, and then we can connect the attribute similar to before, except this time we're using a function that's going to do the TCP connection, request the actual voltage, So we'll take that result and that will be what we return when someone reads the attribute. Similarly, for calibration, we're sending a calibration request to the hardware, and then we're waiting until it's finished by checking the status. So a very simple example. If you want to try this out, just make sure you install the G-Event package simulator that simulates this hardware, uses G-Event. I don't have time to show you that one running. iTango is another way you can talk to Tango devices. So we can run that on the command line. I'll show you that. Exit this one. This is just a wrapper on top of IPython, a few handy features. So you can, again, create device proxies, but it's already imported Tango for me. And it's got this nice tab completion. So it'll create a database for all of the devices that are in the system. And you can even specify the class of the device if you know it, and it'll filter the available devices based on that. We also have the Tango test class. We can connect to it, ping it. Can get attribute list. If we wanted to see what all the attributes that it offers, we could try and read some of them. We could write them. So there's lots of things we can do. And the slides show you a few examples of reading and writing. So here I'm assigning to it, which is writing to the attribute. Another handy feature is this magic mon command, and that lets you basically handle events. So Tango is going to subscribe to an attribute, in this case, on the test device, the state attribute, and it's going to monitor it. So whenever that attribute value changes, Tango is going to see that new value. We can toggle it using switch state. This is a command on the Tango test device. So here we can see there have been 3 different values. We switch states again and run mon, it will show us there's a 4th item. So change default to running. When you're finished, you can use mon-d if you want to stop monitoring that attribute. Mon question mark will give you some additional information about the usage. All right, it's very quick through iTango. If you need more details, you can better read the docs. And it's also the kernel that works inside of Jupyter. So, Nicholas, are you going to take over now?
It's 5 minutes left, Nicholas, okay?
I'll do my best to respect the schedule. Did you see my screen? Or not? No, you don't see it.
Nicholas, can you hear me?
Do you hear me?
Yes, but very low.
Okay, I'm sorry for that.
It's very low.
I have to speak louder, no?
Yeah, or shout. It's 5 minutes left, okay?
No, anyway, I have no time to set up my mic now, so
okay.
Okay. Anyway, so I have a few minutes to say a few words about JupyTango. JupyTango is just a way to leverage the PyTango, iTango, and Bokeh. Bokeh being a visualization library. Features into the Jupyter Notebook. It's a way, if you want to turn the Jupyter Notebook into a Tango client platform, and to have the best of both worlds. It means a command line interface and some GUIs into the same interactive environment. So I'm not going to dive into the installation details, because if you have a look to the Git repository, you will have everything you need to give JupyTango a try with Conda or using Docker. So I'm going to switch to the demo immediately. So if you install JupyTango and launch the Jupyter Lab environment, here is what you obtain. And then we recommend you to try JupiTango with the provided introduction notebook. Okay, so as Anton said, you have ITango behind the scenes. So you have all the completion mechanism you need to select a given device running into your control systems. This is what I'm doing here. If I execute the cell, okay, so it means that my device is not running. I have a console in which I can launch my device. So I'm still in the Jupyter notebook, and I'm running my device from the same environment. So if I try again to ping the device, it works. So here I said that you have all the completion mechanisms. So if you want to, you can directly access any attribute or command of your device. So here, let's say I want to read this one. It's a double image. Okay, you have it. Okay, then I can have a look to the state of my device. Okay, nothing special. It simply means that you have the exact same feature as the ones you can have in Python, IPython. Sorry. Okay, but Jupyter goes beyond that, offering some so-called magics. So, for instance, you have a magic to statically display a given attribute. Here you have a representation of an image, and it's a static representation. So you read it, you display it. You can obviously have the same for a spectrum, for instance. And let's say a word about the graph. And here what you see is some bokeh displays, some bokeh graphs, in fact, because JupiTango is using bokeh to display everything. Okay, but you also have some dynamic monitors. So the main thing in JupiTango is that it is able to deal with asynchronous updates of your monitors into the Jupyter notebook without blocking your cell. It means that I can open another one while the first one is running. Okay. So you get the idea. It means that everything is handled for you in terms of asynchronicity. Okay. And finally, what you can also do is to have some interactive representation of your data coming from your device. But here I open, this is the wave attribute of the Tango test device. And I have a special flavor of the Tango test device. This is the latest version you can find on the GitLab repository. And now you have a new attribute providing you with a way to change the frequency of the wave signal. Here, what I do is to associate a widget with the frequency of my signal. Okay, so it means I can dynamically change the frequency of my signal. So so it means that you can develop a small application, graphical application within the notebook, and have some interactive session with your devices. Okay, that's all for me, guys. And just one word about a repo in which you can find plenty of information on how to deal with asynchronous activity in the Jupyter notebook. Okay, so I will update the README file of the JupiTango in GitLab repository, and you will find all the information you need to find the right notebooks and to play with them. Okay, thank you, guys. I have to stop sharing my screen.
So thank you all. So I'm replacing Giffey. I think he has a technical issue.
So normally Anton is supposed to finish the talk.
Ah, okay.
Well, there's a few more slides that have links. But
okay, can you do it in 2 minutes?
Sure. Yes, lots of links if you want to learn more, examples, Tango's documentation, general Tango documentation. If you have questions, good place to ask them is on the Tango Controls forum. The SK Docker files if you want to see the source for them, and that's where you can download them from. And that's all. So thank you for your time.
Thank you for this great presentation. And thanks all the speakers of the first session. I hope that Gifwe will come back.
I just joined.
We will have a short. Great. Do you want to finish?
Well, thank you all. In fact, I arrived late, so yeah, my computer hung, so I had to do a hard reboot and rejoin everything through WOVA and Zoom and so. No, thanks all. No, maybe now the break we'll have to shift the session some minutes already. No.
Yeah, we can maybe come back in at 3:30. Is it
3:30? Depends on the time zone, no?
Yes, of course. So in 12 minutes.
Okay, see you guys.
So you see you in 12 minutes.
Yeah.
Vincent, are you there? Vincent, are you there? Do you hear me?
It's very low. Okay. So welcome back to the second session. We have some technical problem. I guess it doesn't change from a physical meeting. Nicola, can you shout aloud?
Yeah. Do you hear me, Vincent?
Oh, yes.
Okay. Okay. I switched to my Mac, to my MacBook, and it should be better now.
Stop sharing my agenda. Okay, so Lorenzo,
I don't hear you.
Ready?
Okay. Oh, okay. Sorry, I had a technical problem. So welcome to this second session. So our first speaker is Lorenzo Pivetta from Elettra. And we start with a talk about our historical database, HGB++. So Lorenzo, the floor is yours.
Okay, thank you, Nicolas. So let me share the screen. Okay. So can you see the slides?
Yes.
Fine. So let's talk a little bit about the HDB++. That's the historical Tango database for engineering data. Just a bit of background. This is the list of the requirements back 2012, where basically the idea was to write something new in C++, fast, event-driven, so to exploit the Tango archive event. Our original idea was to be able to do some 1,000 samples per second archiving, but we are now capable of doing some 100,000, which is really good. So flexible, easy to manage, even without opening graphical user interfaces, self-contained with the configuration stored in the Tango database, modular, because you might want to change the backend and move from SQL-based database to NoSQL or different things, and scalable as well. And this archiving system is capable of scaling with Tango, so it's basically exploiting the device concept. And maybe also have some graphical user interfaces for configuration and plotting and so on. So as I said, one of the main points is the Tango archive event. And the archiving system is just based on this concept. So archive event can be sent by Tango devices on value change with respect to the specified thresholds, or on a periodic basis. So we have one important point here is to properly choose the thresholds. So you don't want thresholds to be too small, neither to be too large. So
thresholds in Tango are basically strictly related to the type and the kind of the signal you want to deal with. So the event subscriber is the core of the system. It's a Tango device, which is capable of subscribe to the archive event of a number of devices you specify in the properties. And it's basically the engine exploits a FIFO where a consumer thread puts in the incoming events and the consumer thread is just reading and putting things in the backend. Okay, there were a number of things which this exercise is supposed to do. I won't read every line here, just to say that in addition to exposing the proper interface, each subscriber is also capable of keeping some additional figures that basically is capable of telling whether everything is working fine or something is not working, events are missing, or events are not properly set up, etc. As I said, everything belongs to the Tango database. So when it comes to configure the event subscriber device, you can do that with Jive, well-known tool, the Swiss Army knife. So it's basically, you can specify the attributes the subscriber has to deal with in a dedicated property. For the server, and you can specify the parameters for connecting to the backend in an additional property, basically. You can put some stuff also in the class, in the Tango class for the archiver. So those parameters are easily available to all the instances in the control system. And there's another component which is called Configuration Manager, which is basically a device which simplifies configuring and dealing with event subscribers. It also simplifies adding, removing attributes to the archiving system or moving attributes from one archiver to the other, and setting up also the archive event parameters for attributes which may not have been properly set up. In addition, also the configuration manager keeps some global statistics for the whole control system, so aggregating figures which are kept by each event subscriber. And for the configuration manager as well, the configuration is kept in the Tango database. So for both the device and maybe the class, some configuration looks similar to the event subscriber because also the configuration manager has to know about the backend. On the other side, each instance can be configured to deal with a number of archivers. Okay, when it comes to the backend, the original idea was to have a flexible system. So there's a specific C++ API, an abstraction basically, which allows to easily switch between different backends, and also allows to add a new backend to the archiving system in quite an easy way. So as you can see, we have the abstraction layer and then a number of implementation, which include MySQL, at this time of talking Cassandra, Timescale DB, Postgres, ELK, and also the legacy SQL schema. And of course, this allows also to think to different solutions. For instance, could be quite easy to add a backend to write things on file, let's think about HDF5 or something similar, for instance. So how the HDB++ looks in one single picture. So you have your control system on the bottom with the Tango devices dealing with hardware or logical devices. Then you have the subscribers, which take care to archive the desired attributes into the online database. The subscribes you can configure exploiting the configuration manager and the graphical user interface for configuration. Then typically this central database can be replicated, or you can use analytics if in the case of Cassandra. And on the replica, the clients can query the values and do whatever kind of plotting, etc. they want to do. When it comes to data extraction, there's one thing to keep in mind, is that event-based archiving exploits basically the Tango archive event and the thresholds. So in principle, the archive is not always populated by samples unless you also always specify the periodic archiving as well. So when asking for archived data, it may happen that there's no sample inside the requested window. Some of the implementations are currently capable of dealing with this, basically extending the time window asked for in order to include the last valid sample, or basically returning the last valid sample inside the requested time window. Or you can just stick to the default behavior, which is basically you get back an empty set. When it comes to plotting historical data, so there are a number of options here. You can go for the Qt and C++ client, or you can choose the Java-based client, which is as well capable of plotting multi-lines, tables, and so on. For C++, there's another implementation with similar functionality, but different look and feel. And as well, there's a Python Qt-based implementation, also capable of retrieving data from the historical database and maybe joining also live data from the devices. Or if you prefer, you can decide to use a web-based plotting tool, which is Egiga, as well. As I said before, both devices in the archiving system, so the subscriber and the configuration manager, you can configure using the standard Tango tools, or you can configure exploiting some few Python lines, etc. But there's also a graphical user interface to configure devices, which is called HB configurator, where it's not very different from Jive. You have the usual device tree on the left, and then you select things. You select the attributes you want to archive. You can specify the thresholds. You can specify the archiver. You can specify the time to leave and so on, and just click Add to Archive. And the same tool also provides a graphical user interface for diagnostics, where you can see in one GUI basically all the instances running with the statistics each instance is keeping for you. So it's basically where whether there are faulty attributes, how many has been started, whether there are paused attributes, stopped, and so on.
Lorenzo, you are running out of time.
Okay, I'm also finished. So if you want to try HTTP++, it's best to go for the latest one. So go to GitHub, and it's quite easy to build using CMake. And there are also a few SQL files you might want to use to automatically set up the schema for the backend. So thank you for your attention, and this is the collaboration team.
Thank you, Lorenzo. Thank you very much for this presentation. I suggest to if you have some question, let's say that we have open room for that. So we immediately switch to the next speaker. Our dear colleague Zibi from Alba will give you a talk about Sardana, a tool to control the beam lines. Zibi?
Thank you, Nicolas. Can you hear me?
Yes, we can hear you.
Okay, so let's start. This will be a very short introduction to Sardana. As prerequisites, you need a Tango database running and the Tango test device server running, and this GitHub repository clone, where you will find a step-by-step guide on how to reproduce the demos that I will make during this presentation. Okay, let's first answer the question, what is Sardana? So we call it a scientific SCADA suite. Within this suite, we have two projects, Sardana and Taurus. These are independent projects, but very closely developed. Both are 100% written in Python, and Sardana suite is built on top of the Tango control system. It contains of 4 pillars. We have on the client side, Taurus-based graphical user interfaces. Taurus library uses PyQt underneath. Then on the client side, we also have command line interface based on a Python, which is called Spock. And on the server side, we have macro server, which is a powerful sequencer capable to run either built-in macros or custom made macros. It also comes with a scan framework and a data storage solution. And also on the server side, we have device pool, where all the hardware is interfaced. It provides common interfaces to the laboratory equipment elements, and also some abstraction layers. Both Sardana and Taurus are extendable with plugins and are highly configurable. You can install Sardana with either Debian packages from Python package index or using Conda. And here I will use a Conda installation in the demos. So let's start the first demo. I will create a Sardana simulated environment. We call it Sardemo, where we will create one device server instance. We will populate it with some simulated elements and then connect to it from a Spock command line interface. So let's start. So in one terminal, I will start the Sardana server, and in another terminal, I will start a Spock client, which will connect to one of the devices exported by the server, which is a door. And here we could already list the built-in macros. So we can see that we have a catalog of built-in macros and their names, and try to follow the spec control system naming convention. So we have the macros for scans, like for example, the relative scan, the scan. We also have macros for diffractometer control. And also we could list the elements that we have in Sardana. We can see there are no elements. So I will run the Sardemo macro to populate the server with some simulated elements. Here we could see them now that we have some experimental channels, some motors, pseudo motors, etc. And this was basically the first demo. Now I will switch to simple motion control. Yeah? For these needs, we will use Spock And also we use some Taurus widgets. Yeah, so let's start first Taurus form that will provide you a very simple widget for controlling a motor. And I will start another widget, which is a Taurus trend that will monitor motor's position attribute. And now I will jump back to Spock. And here I can use one of the built-in macros, which is the update move macro, and move this simulated motor to absolute position 100. And we can see how the widget is getting updated with the new position, and also how the trend was following the displacement of the motor. Now I will do the same thing, but from the graphical user interface, just by pressing enter. On the widget, we were moving back to 0. All the motors in Cardano, they have some standard interface. They have some Tango attributes. One of these attributes is, of course, a position that we are monitoring on the trend. But there is another one, for example, a velocity, which actually now is 100. And I will change it to 10 and repeat the move. That we will see that the slope of the displacement is a head change. Yeah. So this was basically about the motion control. And I will now switch to the data acquisition. So in Cardano, we have different type of experimental channels. We have channels for scalar sensors. We have channels for one-dimensional sensors like MCA, for two-dimensional sensors like the detectors, CCD cameras, etc. And we have also similar macros for executing a very simple data acquisition, and also a Taurus form widget for doing it in a graphical way. I will not do the demo about data acquisition, and will pass directly to the Taurus graphical user interfaces. So now I will show you how to create a complete Taurus graphical user interface that will connect to the Cardano system that we just created without programming a single line of code. So let's go back here and maybe close the other widgets and start here a wizard that will create a new graphical user interface. First, we need to specify in which directory we would like to store this project. Let's call it demo GUI, choose it, and then proceed, give a name to the application. And then we could select an active synoptic that we would like to use in this application. So I have one already prepared in the repository I mentioned you before. This is demo beamline, and I will proceed and also select to connect to our macro server and create some panels for instruments. And I will proceed till the end of the wizard, which created me a complete Python project and offers me a way of installing it. So I will now proceed with the installation, and we could already start our graphical user interface. Okay, so it provides us a complete application with some built-in panels for executing macros, etc. And I will make you a quick demo of how to use the active synoptic and instrument panel. So I will start with a blank page, and here I will open the active synoptic. So it shows me the layout of my beamline, where I could select the panels by clicking on the synoptic. Yeah, so this is one of the panels for controlling the mirror instrument, and then we have other panels for other instruments. I will tap them on the top, and you can see how by clicking on the active synoptic, it also gives a focus to a different panel. And also the other way around, when we change the panel, it also changes the highlighted area on the active synoptic. And this is basically the demo of this part of the Taurus GUI. I will store it as an independent perspective. Let's call it instruments. And now I can start another demo, and I will show you how to connect to a Tango control system by first creating a panel for browsing a database, where I will tell it to connect to a Tango database to my host. I specify the Tango host name. It opens me a browser of a Tango database, and now we create two more panels, one for with a form, an empty form, and another one with an empty plot. So I said you that we have a Tango test instance running, so we could try to navigate to it and select some of its attributes and maybe drag and drop them to the form. So in this way, we could monitor the attributes from a Tango control system. We can also store it as another perspective. Select these new panels that I just created as permanent panels, and then we could quickly switch from one perspective to the other. Okay, I will move on now to tell you a little bit about the Taurus library. So Taurus library is data source agnostic. It uses a model view pattern, so it has some generic widgets. We saw form, trends, and plots. And it also instantiates some specific models. And these models are provided by plugins to Taurus library called schemes. So there are schemes for Tango, for ICALEPCS, and others as well, and you could provide your own plugin to connect to your data source. Now I will change the topic and move to scans.
Three minutes left.
Okay, so Sardana comes with a scan framework. It provides step and continuous mode of scans and some turnkey scan macros. It also allows you to develop your custom scans and also has a data storage mechanism based on plugins called recorders. To develop custom macros in Sardana, it's very easy. You have plenty of features that you could use, like for example, plotting. Macros can be interactive. They can have input and output parameters and be reloaded at runtime. So I will show you how to do it. For example, in Spock, we could use a magic command at Mac and create a macro hello and place it in the ICALEPCS module. And here, and the template offer me some help. I just need to import one more decorated, which is an interactive macro, and ask the user for an input. And for example, what is your name? And with this name, we could feed the user saying hello. And we save it and store it on the server. And now this macro should be ready here. And it asks us for the name, and the macro is greeting me, hello Z. So this was the way of plugging your own macros into the Sardana system. And the last thing is I would like to show you is how to plug in your own hardware into your system. So base it on the example of a motor. So motors are exposed in Tango World as motor devices. They have some attributes, some commands, but underneath we have motor controllers, which are simple Python classes that we need to implement. So I will make it on the example of a Blender slits, which let's imagine that we receive an instrument, which is this kind of beam slits. Yeah, we render it here in with Blender, and we receive some communication protocol, and then we just need to implement a class that inherits from a motor controller class and implement a bunch of methods. Very simple. To start the move, check the state, read the position. Yeah. So I have this controller already loaded here. It is here, and I also created a macro that will instantiate in the whole system, that we create a controller instance, some motors, calibrate them, and then also create some pseudo motors so we could operate it with gap and offset. So I will just run this macro, create Blender slit, and it creates a slit and also open it a little bit. And now I will have a possibility to move the horizontal gap. So gap and horizontal a little bit more. So it expanded the gap now. And now I could make a scan, a relative scan of offset vertical from -5 to 5 with 10 intervals and 0.1 seconds. So it is now scanning this emulated hardware, yeah, the beam suite. Okay, and just to finish, just 1 minute more, Nicolas, sorry. So Sardana and Taurus are community-driven projects. So there are approximately 50 applications of Sardana in different institutes in Europe. And also we have a very strong community of users and developers. Here I post you a couple of links to our documentation, our projects, and some other secondary sources. And with this, sorry, and thank you for your attention.
Thank you, Zibi. Thank you for this amazing and very impressive presentation. Thank you very much for that. Okay, so the next speaker is Yimeng Li. Sorry, if, do I pronounce your name properly?
Yes.
Okay, good.
Nicola,
Okay.
Nicola, this is a breakout session.
Oh yeah, really. Because okay, I don't have it in my agenda here, so sorry. So the floor will be used in a few minutes. Okay. So we have a break. No, this is a breakout session. Sorry, yeah. I'm lost. Sorry, I'm the worst chairman you can find. So this is a breakout session. So we have a first session regarding Taranta in the Shanghai room. Okay, and in parallel we have a hands-on session about walls, a web solution. By Igor, and it will be given in the Beijing room, right? Okay, so I invite you to choose which room is yours. So have a nice session in these dedicated rooms, and I show you in 15 minutes.
So in the meantime, if there is people that doesn't know how to go in the breakout room, we can help. So for the people that just arrive, and so there are palaces session. One is Tanta in the Shanghai breakout room, and the second one is Warts in the Beijing room.
Okay, we are back in the main room. So what is the status of the parallel session in the other room? So
Toronto one is complete.
Let me check the status of the other presentation. I'm back in a minute.
Yeah, I sent a message to.
Okay, please, Vincent.
Yeah, have you seen my message in the session?
Yes.
Yeah. Okay. I can do